Bismillahirrahmanirrahim. Hello everybody, this is a special lecture since the most of the students are not present in the amphitheater. Let us begin as they are here. They are only 4 students from Algiers. They are near the university. The title of the paragraph of today will be Integration of fractional function. For example, we will start by an example. How we can deal with these 2 examples. The first one, if we have to integrate f of x, which is equal to x squared plus 1 over x squared minus 1, for example, and how we can deal with a function f of g of x if it is equal to x plus 1 over x squared minus 1. So the idea, we have here 2 cases. We remark that here the order of the numerator, polynomial of the numerator is strictly less than of the denominator. So here we can just take the elementary ration, but here we have the same order or more. In this case, we have to start first by an Euclidean division with increasing powers. Then we can use the natural method. So we start by the first one. We take x squared plus 1 over x squared minus 1. We can add here minus 1 plus 1 just to avoid the traditional Euclidean division. This gives us x squared minus 1 plus 2 over x squared minus 1, which is equal to 1 plus 2 over x squared minus 1. So in this case we can integrate. We will deal with this case later. For the second one, we have g of x, which is equal to x plus 1 over x squared minus 1, and this is equal to x plus 1 over x minus 1 times x plus 1. Since the order is strictly less than of the denominator, this gives us a over x minus 1 plus b over x plus 1. Same for this case. This gives us 1 plus a over x minus 1 plus b over x plus 1. How we can determine the coefficient a and b? We can do it with many methods. One of these methods consists to take, for example, x plus 1 over x squared minus 1. This is equal to a times x plus 1 plus b times x minus 1 over x squared minus 1, and it is equal to a plus b times x plus a minus b over x squared minus 1. by identification, we can get, by identification, we can obtain the linear system, which is a plus b equal to 1, and a minus b equal to 1, and a minus b equal to 1, I plus b equal to 1, this one, the coefficient of x, and a minus b equal to 1, this one, the coefficient of the power 0, x power 0. From what we can get a equal to 1, to a equal to, so a equal to 1, and b equal to a equal to n plus, it gives us I equal to 1, and b equal to 0. This is wrong. There is something which is wrong here. Yeah, for sure. Yeah, for sure. We can take this bad example. So let us take here, because we can simplify. Let us take this example, 2x plus 1, and in this case we get here 2x plus 1. The first one is okay. For the first one is okay. In this case we have a plus b equal to 2, and a minus b equal to 1. So from the first one, we get 2a equal to 3, then a is equal to 2 over 3, and a minus b equal to 1, then a equal to a minus 1 equal to b, which gives us b equal to 2 over 3 minus 1, so minus 1 over 3. In this case, so for the second one, g of x, this is equal to 2 over 3 over x plus 1, x minus 1, minus 1 over 3 over x plus 1. For the first example, the example of f of x, we have a over x minus 1 plus b over x plus 1 plus 1. This is equal to f of x. In this case, f of x is equal to f of x is equal to 1 Let me write it once again in a more clearly way. F of x is equal to 1 plus 2 over x minus plus 2 over x minus 1 times x plus 1, and this is equal to 1 plus a over x minus 1 plus b over x plus 1, which is equal to 1 plus x minus 1 times b plus x plus 1 times a over x square minus 1, and this is equal to 1 plus a plus b times x plus a minus b over x square minus 1. From what? So we have 2 over this. From what we deduce that a plus b equal to 0, and b, we have b minus b, yeah, a minus b equal to 2. From what we get a equal to 1, and b equal to minus 1. Then f of x is equal to 1 plus a, so 1 over x minus 1. If we add, so we get here, we get to a equal to, so 1 over x minus 1 minus 1 over x plus 1, and g of x is equal to g of x is equal to 2 over 3 over x minus 1 minus 1 over 3 over x plus 1. So to integrate both of this function, we get here that the integration, the undefined integral of x is equal to x plus ln absolute value of x minus 1 minus ln of absolute x plus 1 plus a constant. Very easy. And from here we get that the undefined integral of g of x is equal to 2 over 3 ln x minus 1 absolute value minus 1 over 3 ln absolute value of x plus 1 plus constant. So in both cases we can integrate the functions in a very easy way. This is just two examples to understand the way that we are supposed to flow. So in a more general case, we can follow the well-known methods that deal with these cases. You can ask questions. So suppose that we have we start first by decomposition of the relation of polynomial p of x over q of x, f of x, into elementary polynomials, elements. We mean into a polynomial of type f, ax plus b, or ax squared plus bx plus c. Here we distinguish two cases. The first case, if the degree of p is greater than or equal of the degree of q, then we proceed, we take the Euclidean division to this function such that p of x is equal to q of x times s of x plus a remainder r of x, such that the degree of r is strictly less than the degree of q. Yeah, to get f of x equal to p of x over q of x, which is equal to s of x plus r of x over q of x. And don't forget that the order of the polynomial r is strictly less than the order of the polynomial q. So without loss of generality, we can suppose that for the function f of x, which is equal to p of x over q of x, we have the order of p is strictly less than the order of q. We are in the second case. We replace r of x by p of x. In other words, if we have this case, we can easily integrate. We can easily integrate all polynomials. We know that from higher primary school or higher school. So in this case, we have cases. The first case, q of x is equal to a1x plus b1 times a2x plus b2 times anx plus bn. In this case, we get f of x, which is equal to p of x over q of x. This is equal to, we will be decomposed on elementary fraction as a1 over a1x plus b1 plus a2 over a2x plus b2 plus till a index n over a n x plus bn. E from 1 to n are real numbers to find, and we have many ways how to find a1, a2 till an. So in this case, how we can integrate the function? So we have here ln here the primitive f of x dx is equal a1 ln a1x plus b1 etc. to an ln anx plus bn plus a constant, and this can be write like as from e equal 1 to n ae ln absolute value of aex plus be plus a constant. Very easy, as you know. This is the first case. The second case, The second case, in the same situation, so we have the degree of P is less than the degree of Q. If not, we can always be back in this case. So we take the Euclidean division till the degree of the numerator will be less than the degree of the denominator, and we will proceed in this sense. So the question isn't about how to integrate a polynomial, but how to integrate a fraction. This is the question. In this case, the second case, suppose that f of x is equal to p of x over q of x, which is equal to p of x over a1x plus b1 power n1 times power k k1 times a n x plus bn times kn. Suppose that we are in this situation. If we are in this situation, the decomposition is a little bit long, but it is very simple, basically simple. In this case, f of x, which is equal to p of x over q of x, in this second case, takes the following form. It is equal to a1 over a1x plus b1 plus a2 over a1x plus b1, the same elementary function power 2, plus a k index k1 a k1 over a1x plus b1 power k1. This is just for the first element, plus for the second element we do the same, etc., until the last one. So for the last one it will be an, so we have here an 1 1 2 1 k1. So the first one, the last one, an, so an 1 over an x plus bn plus an 2 over an x plus bn power 2 plus etc. to an k index n over an x plus b n power kn. How we can integrate this? It is basically simple. Why? Because here we are dealing of at most two cases, different cases. The first case, we have to integrate. So if we integrate f of x dx, in this case we will integrate of this. The first one will be a 1 ln absolute value of a1x plus b1. Starting from the second case to the final case, it take the general form. So this is the sum from e equal 1 equal 2, from e equal 2 to k1, the second one. We have a1e divided by 1 minus k1 times by a1x plus b1 power 1 minus k1 but in all these cases since we take here ae, so here we take ae, so in all these cases this will be divided by a1 and divided by an, because we take the polynomial anx. Do you agree? Okay, if we have to make this change of variable, so here we have ae, and here once again I take the more general case. In this case, so here we have divided by a1, and here divided by a1 times a1 plus an1 over an ln absolute value of anx plus bn plus the sum from e equal 1 to k n ane over an times 1 over 1 minus kn times an plus bn power 1 minus kn plus a constant. For example, if you take the derivative of this one, so we get anx. If we take the derivative of this one, it will be what? It will be 1 minus k1, so it will be cancelled. Then we have anx plus bn power 1 minus k1 minus 1, so we lost 1 with minus 1, so we get just minus k1, and here we have the derivative of this one. The derivative of this one will be an, so we simplify an with an, and we get what we have as elementary function. So here we just had two cases. Let us move to the third case. The third case For the first case, we suppose that f of x is equal to p of x over q of x, which is equal to p of x over a1 x squared plus b1 x plus c1 times an x squared plus bn x plus cn, such that delta, which is equal to be squared minus 4 aece is less than 0. So in this case, we suppose that the delta is less than 0. This means that this is an irreducible polynomial. We cannot have more roots in this case, and we suppose that for all this polynomial of order 2 have the discriminant is less than 0. So we cannot put them in this elementary case. Okay? So in this case, and we suppose that the order of P is strictly less than the order of Q, what we can do, the function f of x takes the elementary decomposition into elementary fraction, polynomial fraction, as we have a1 b1, so it will be a1 capital 1 x plus b capital B over a1 x square plus b1 x plus c1 plus until a and x n x plus b and x n over a n x square plus b n x plus c n. They take this decomposition such that a and xe and b and xe are real coefficient numbers to determine. And there is algebraic technique that we can use to determine this coefficient. The fourth case and how we can integrate this is the question before passing to the fourth case, how we can integrate the function f. So to integrate f of x dx, we have to integrate a1 x plus b1 over a1 x squared plus b1 x plus c1 dx until arriving to integrate a n x plus b n over a n x squared plus b n x plus c n dx. We can just deal with one example. Let us integrate the case, for example, ax plus b over ax squared plus bx plus c dx. This case will be equal to a divided by a by 2a, the integration of 2ax just ax plus b, 2ax plus little b over ax squared plus bx plus c minus, so here we add b, then we take off b, minus or plus b minus little b over 2a, the integral of dx over ax squared plus bx plus c. Do you agree? Nordin, it is okay? For the first one, this is equal to a over 2a, the ln of the absolute value of ax squared plus bx plus c. And for the second case, we know how to deal with this case. We already seen this case, and you can find it in some previous video. I detailed this case, both of them. So this is how to deal with the third case. The fourth case, for the fourth case, in this case, suppose that f of x in the same condition, the degree of the order of p is strictly less than the order of q, and suppose that we have p of x divided by a1 x squared plus b1x plus c1 power k1 times an x squared plus bn x plus cn power k1, such that k1 to kn are natural number, positive natural number. In this case, the decomposition into elementary elements will take this form. So it takes this form. F of x takes the form ay11 x plus b11 over a1x squared plus b1x plus c1 plus a12x plus b12 over a1x squared plus b1x plus c1 squared plus a1 k1 plus x plus b1 k1 over a1x square plus b1x plus c1 power k1 plus dot plus the last one will be an 1 x plus bn 1 over an x square plus bn x plus cn plus this just for the first element, and this for the last, an x square plus bn x plus cn plus an2 x plus bn2 over an x square plus bn x plus cn power 2 plus an kn x plus bn kn over an x square plus bn x plus cn power k and x n. This is the decomposition of this case. طويلة. Yeah. How we can deal with integration for the first ones, for this one and this one, it's okay. So we will be in the third case. But how about the remainder? For the remainder, the question here, how we can integrate the function of the form ax plus b over ax square plus bx plus c power k dx. How we can integrate this function? If we answer this question, we will be able to answer for all this. How to determine an1 to an kn and bn kn? See, by identification, it is simple but a long way. And we have tricky, we can use the tricky to find in some cases more easily than in other cases. So our purpose, the main goal for this moment is how to integrate this one. For sure, the delta, the discriminant, is less than 0. Even we will get basically solutions. We suppose that this polynomial is irreducible. This is irreducible, and then what we can do, we cannot find more solution, more roots. Okay, even if we can find more roots, it will be the second case. So here we have b square. So to integrate this one, the ax plus b over, this is a bad pen. To integrate this case, ax plus b over ax square plus bx plus c power k. It seems that this one is also bad, a bad one. It's clear? Can you distinguish the, okay. So in this case, what we can do? Here we have a delta, which is b square minus 4ac is less than 0. Even we will be in the second case. So it takes the form the integral ax plus b over 1 over a times here x square plus b over ax plus c over a power k, and here we have a power k. This is equal to 1 over a power k, the integral of ax plus b over, here we have x plus b over 2a square. We get x square plus b over ax, so we take off plus c over a minus b square over 4a. All of this is power k. Do you agree? 4 x plus b over 2a square. This gives us what? This gives us x square plus b over 2x. Okay, but we have b square over 4a more, so we take it. It will be minus.
But 4a squared minus 4a.
Yeah, thank you. Yeah, a square. Yeah, okay, I agree. So this is equal to 1 over a power k, the integral of ax plus b over, here we have x plus b over 2a square plus we have 4ac minus b square over 4a square over k dx. Do you agree? But this is negative. If this is negative, this means that this is positive. Okay. And then we can write this as 1 over ak. I think that I need more place. Let us denote by 4ac minus b square over 4a square. Let us call this m power 2. If we call this m power 2, we get here, we will get equal to 1 over a power k, the integral ax plus b over x plus b over 2a square plus m square power k dx. And this case takes the form 1 over ak power k. We take m square out of this integral, so it will be m2k. The integral of ax plus b over, here we get here 2ax plus b over 2m square plus 1 power k. Do you agree? Nordin, Muqdad. We take off m square out of the integral. So it takes this form. And let us make the change of variable. Let us put t equal to 2ax plus b over 2 capital M. In this case, dt 2 capital M dt equal to 2a dx. Then dx is equal to 2 capital M over 2a dt. And x from this we have t equal to a x plus b over 2 capital M, implies that 2 capital M t equal minus b over 2a. This is equal to x. Then this integral, this is a little bit long, so this integral takes the form, turn to the following form. So this implies that E will be equal to, help me please, a power k, capital M power 2k, the integral. We have ax, so we have ax. This means that we have a to m over 2am over t, it is x, it is here, 2ma over 2a, 2 little a times t minus b over 2a plus capital over so we have here we have t squared plus 1 power k dt. dt is equal to, dx is equal to 2m over 2a dt. And this takes the form, the following form. So it takes the form for the first one. So we have 2m to e will be considered with this one. No, not with this one. So this take 1 over a power k capital M to k times 2a m over 2a, the integral of t dt, we use those, not yet. So here we have 4 for this, we have 4 m square هذو مع هذو, so over 2a, so we have 4a square t over dt over t squared plus 1 power k minus or plus 1 over a k m power 2k times this one, so times b minus b over 2a times 2m over a 2a, the integral of dt over t square plus 1 power k. So we have a coefficient. It doesn't matter its value, its form, but the most important case is how to integrate this one and how to integrate this one. So the principal aim now is how we can integrate the two following integral. So now we need to integrate t dt over t square plus 1 power k, this one, and how we can integrate dt over t square plus 1 power k. So this is E and this is G. Do you agree? We transformed our problem to these two integrals. So to be able to integrate integrate a function of the form ax plus b over x squared plus b x plus c power k, term to be able to integrate these two ones. For this is very easy. This is equal to 1 over 2, the integral of 2t over t squared plus 1 power k dt. This one. And here we recognize that this is a derivative. This one is a derivative of what? 1 over 2 times هذه. Which derivative? This is a derivative. So this is a derivative of what? So 1 over 2 times 1 minus k t squared plus 1 power 1 minus k plus a constant. If we take the derivative, it will be 1 minus k minus y minus 1. This means minus k. It takes the 4. We cancel 1 minus k with minus k. And here we have the derivative t squared plus 1 power 1 minus k minus 1 times the derivative of this one, which is 2t. So this is the first. How about this? This will take more time. For this one, we will find a recursive formula to integrate this one. So to do, let us write it as follow. This is equal to 1. This pen is, it seems that it is bad. This one, yeah. This 1 times 1 over t squared plus 1 power k dt. Then we suppose that this is u prime and this is v. So it gives us what? It gives us t times v. Integration by parts, per parts. Integration EPP gives us t, so it gives us t over t square plus 1 power k minus the integration of t times the derivative of this one. It gives us what? What can this gives us? It gives us the derivative of 1 is 0 minus, so 0 times the denominator is 0 minus the derivative of this one. So minus, with this minus it will be plus. So k times 2t times t square plus 1 times k minus 1 over t square plus 1 power what? Power k, 2k. So all of the denominator power 2, so it gives this as dt. We will write it once again now. We will take it and write it here more clearly. So this is equal to, we have g index k, which is equal to dt over t square plus 1 power k. This is equal to t over t square plus 1 power k plus 2k the integral of 2t square, we have here t and here t, over t square plus 1 over 2k minus k plus 1 dt. We just write the formula. Okay. Sure. Yeah. So here we have k plus 1. Here we have 2 square, and the second side can be write as t square plus 1 power k plus 2k. شد مد يا أحمد. So we can take t square plus 1 minus 1 over t square plus 1 power k dt. And this takes the form t over t square plus 1 power k plus 2k, the integral dt over plus 1, sorry, t square plus 1, just this one power k, minus 2k, the integral dt over t square plus 1 power k plus 1. Do you agree? And I think that we find once again that this integral is exactly this one with different coefficient. Then we can deduce that we take this from this side. No, we take this from this side. It will be 2k. How we can denote this? Using g index what? G index k plus 1. So 2k g index k plus 1 is equal to t over t square plus 1 power k, this one, plus 2k minus 1 g index k. For k, starting from 2 to plus infinity. So this is the formula. Here we can't find the successive integral by using this recursive formula. This is the way. It's not short, but this is the way. So here, I think that we deal with all the cases of polynomial, all the cases. We can, for example, take example. So we will deal with some example. The hour, the time. العشرة و20. So I will put more examples in the channel YouTube channel. I think that we will stop here. Thank you very much for attending this session and for watching this video. I hope that I will see you next time.